In this video, we're going to evaluate a few different integrals using a graph, and by finding the area of different geometric shapes to evaluate the areas under the curve. This first problem is the integral from -1 to 1 of f of x dx. The boundaries for the integral are between -1 and 1, so we want to focus just on the space of the graph for x values between -1 and +1. That area would represent half of a circle with a radius of 1. If the area you're looking for is above the x-axis, this is going to be a positive area. But sometimes we might be finding the area of something that's below the x-axis. In that case, you would want to make the area negative. So then to evaluate this integral, we just need to find half of the area of a circle with a radius 1. The equation of a circle is pi r squared, so in this case we would just have 1/2 of pi times 1 squared. This is equal to pi over 2. The next problem is the integral between 0 and 4 of f of x dx. So we just want to concentrate the part of the graph between x equals 0 and x equals 4. That would be this space here. We only need half of that half circle that we used in the first problem. So the area between 0 and 1 is going to be 1/4 of the area of a circle with radius 1. And then from 1 to 4, notice that the graph exists below the x-axis. And then that is a triangle with a base of 3 and a height of 1. So we need to calculate the area of 1/4 of a circle of radius of 1 that is above the x-axis, and then add that area with the area of a triangle with a base of 3 and a height of 1 that exists below the x-axis. The area of a circle is pi r squared, so then the area of a quarter of a circle with a radius of 1 would be 1/4 pi times 1 squared. Since the triangle is below the x-axis, we need to subtract its area. Therefore, we'd have minus 1/2 times 3 times 1. And then this would give us pi over 4 minus 3/2. Part C, the integral from -3 to -1 of f of x dx. Between -3 and -1, the area under the curve is a triangle. This triangle has a base of 2 and a height of 2. So we need to find the area of a triangle with base equals 2 and height equals 2. That would give us 1/2 times 2 times 2, which is equal to 2. For part D, we have the integral between -3 and -4 of f of x dx. Between -4 and -3, this is a triangle that is below the x-axis. It has a height of 4 and the base is equal to 1. We need to be careful here. In order to use that graph, the bottom boundary has to be smaller than the top boundary. Right now, the bottom boundary is bigger than the top boundary. So we need to reverse the order of integration. Well, there's a rule for that. If you reverse the order of integration, you have to put a negative in front of the integral. And now we can use the area of that triangle to evaluate the integral. Since the triangle was below the x-axis, we would have -1/2 times 1 times 3, and then there's still a negative hanging out front of everything. This would simplify to a positive 3 over 2. Finally, we have the integral from 1 to 4 of f of x plus 3 dx. Once again, we need to be careful with this. You can't just evaluate the area between 1 and 4 and then add 3 at the end of it. Instead, consider what f of x plus 3 really means. You might remember from algebra that if you add or subtract a value at the end of a function, that this is a vertical translation. So adding 3 to f of x literally moves the whole function up 3 units. We're only concerned about the graph between 1 and 4. So we're going to take that line segment and we're going to translate it straight up 3 units. That first coordinate of 1, 0 translated up 3 units would be at 3, 0. And then the second coordinate at 4, -1, if we translate that straight up 3 units, we'd be at 4, 2. So this is our new line segment, and we're trying to find the area beneath this line segment between x equals 1 and x equals 4. The shape of this is a trapezoid, so we just need to find the area of this trapezoid. Our b1 and b2 in this case would be 3 and 2, and then our delta x, the distance between b1 and b2, is equal to 3. Therefore, this integral would be equal to 9.